Hello, welcome to the sessions. Today we are going to solve a problem related to Jouling effect of current. Jouling effect means heating effect. Okay, this is the problem. Three 10 ohm 2 watt resistors are connected as shown in figure. Right? Means we have 10 ohm resistance. Here 10 ohm resistance and here 10 ohm resistance. Okay? All resistors are connected, means two resistors are connected in parallel and one connected in series, and rating of these resistors are 2 watt. Okay, the maximum possible voltage between A and B without exceeding the power dissipation limit of any of the resistors is, we need to find out. Okay, why this watt 2 watt is there? Why? And what is the meaning of rating of any resistor? If you have any resistors, is it possible to pass current without damaging them? No. Is it not possible? Let me just choose some minimum. Yeah. It is not possible like to pass any much amount of current on any resistance. Let's assume you have some R resistance. Depending on the material, you will have some maximum amount of current which this resistor can sustain. Okay, for material 1 type of 10 ohm or some ohm of resistance, this can sustain, let's assume, approximately 0.5 ampere. Okay, if you increase this current, if you go beyond 0.5 ampere, this will get burned out. Why? Because I square R is a heat which will generate over here, and if this material do not have the capability to sustain 0.5 square into 10 joule energy, then this will get burned out. Okay, if you change your material, means M1 to M2, probably this current, means this current may change, means it may sustain more current, it may sustain less current. It means we have to have some specification in terms of how much current one resistor can allow. Why current is important? Because resistance for any materials are fixed. R is fixed, irrespective of your voltage, irrespective of your anything. R is fixed. If you know I, max allowable I, then you can calculate, means maximum allowable I will dictate, okay, you don't need to go beyond that I. Why? Because if you go beyond that, it will generate I square energy and that material will get burned out. This discussion I mean, like, I is very important for any given specification, for any resistor or for any electrical devices. I is very important, and directly or indirectly you will find in any questions I would be given. Here indirectly I is given. I will tell you how. This is 10 ohm resistance, this is 2 watt. 10 ohm 2 watt means power is given, P is equal to 2 watt. Okay, and we know the equations. I square R is equal to P. P is equal to I square R. We can calculate I, maximum allowable current, right? Because maximum allowable power is 2 watt. 2 watt it can sustain. We can calculate using these equations what would be the maximum allowable current for this resistor, and that would be turned out like P is 2 and resistor is 10 ohm, means total current that this resistor can sustain would be 1 by root 5. 1 by root 5. Okay, so this is the specification. This is the maximum I this can sustain, maximum I this resistance can sustain. Here if we put here I max 1 by root 5, then what will happen here? Also you will have I max 1 by root 5, then here you will get 2 times of I max 1 by root 5, and this resistor will get burned out. It means we have to have this I, means this I should be equal to 1 by root 5. It should not be more than that. Sorry, not root 2, root 5. It should not be more than that. Means total current from here, if you put some voltage difference, some battery, then total current which this battery can supply should not exceed by 1 by root 5. Okay, it means we know how much current this battery is going to push into this circuit. Means we know the limit of the current that this whole circuit can sustain. That limit of current is 1 by root 5. Okay, if for example, just for example, if this 10 ohm, this resistor, if you omit this resistance, in that case, if you have only 2 parallel resistance, in that case total current may get increased, because in this case if you don't have this resistor, then you can push 2 by root 5 current, because this 2 by root 5 current will get divided into 1 by root 5 and 1 by root 5, and both the resistor will sustain that much of current. But here, because you have one more resistance in series, we cannot increase the current limit by beyond 1 by root 5. Okay, this is the limiting value of current. 1 by root 5 is the limiting value of the current that we need to remember. Okay, now we need to find out how much potential we can put across this, right, so that this resistor should not get burned out. Okay, now we need to we know the maximum current. We can find out the total resistance. Total resistance of this circuit, means from A to B, total resistance from A to B or AB should be equal to this 2 parallel resistance, means 10 ohm parallel to 10 ohm, we write like this, and is in series with 10 ohm resistance. It means we will have total 5 plus 10, total 15. 15 ohm is the total resistance of our AB. Then how much current? How much current we can get? Oh, sorry, we need to calculate the voltage, right? Then how much voltage we can apply across AB so that this current should not exceed 1 by root 5. That will be RAB into I max, and this I max is this 1 by root 5. You put it here. This is 15 divided by 1 by root 5. Okay, this will be equal to 3 root 5, and this answer is correct. Okay, alright, hope you understand. Bye bye, see you in the next lecture.